Hi, good afternoon, everybody, and welcome to Training Tuesday here on the 18th of February. Hopefully you're staying warm. No, it's not all that warm outside right now. So what we have here is we have this presentation, as always, is intended for training purposes only. For technical specifications and products mentioned within this training, refer back to DaytonSuperior.com. And for those of you that are regulars, you notice I am not Heidi. My name is Chuck Hoke. I'm here. I'm going to be doing the presentation today. Heidi is tied up with another engagement right now. So let's start with who is Dayton Superior. We are the leading provider of engineered solutions in the concrete construction industry. What does that mean? Accessories, chemicals, forming, engineering, and training. It is a bundled package for all the products that we typically carry. You can basically combine any of the accessories with the chemicals, including the forming. Obviously, we have engineering to back everything up. And obviously, as Heidi and I do, we do our training thing. So, what do we have? Bar supports, bridge deck, precast splicing, tilt up light and heavier wall forming. You're also looking at brand names such as Taper Lock for the splicing, Sleeve Lock and splicing, Bar Lock, AccuBraces in the tilt up world, Tilt Works in the tilt world, along with all the chemicals from the liquids, powders, and epoxies from repair and restoration all the way through to new construction. Uh, Branded names, Dayton Superior Chemicals, and Unitex products. And obviously, we have our forming division with Simons, one of the oldest brand names in the industry, 124 years old, if I'm not mistaken. Been around for a long time here, and you're talking systems such as STS, Simply, Steel Ply, FlexForm, Spacelift, Garage Beam. And the list goes on, and especially now we're talking in any of the shoring systems also with deck fast and drop pad and soldier beam. So today we're going to talk a little bit about precast hanger solutions for, once again, precast beams. So when we're talking precast girders, we are looking at those girders that are typically cast in a shop, transported to the job site, and the bridge is then erected from that. Now, the first pre-stressed precast bridge beam was actually built in 1950 over in Philadelphia. Uh, Bridge beams have been precast for, well, we're a better part of 75 years now. Lengths typical, well over 100 feet. And you're going to see in the next statement here, the longest pre-stressed bridge beam was 223 feet. And that was actually up in Tacoma, Washington. It was produced by Concrete Technologies Corporation. And that beam itself weighed 240,000 pounds. So, but typical I-beam construction here, you're usually looking at typical standard I-beam, box beam configurations. You're looking at anything from a short box beams, 40 feet, all the way up to about 100, 120 feet are standard in today's marketplace. And obviously, with this job up in Tacoma just a couple of years ago, you're talking, this is a pretty monumental step, 223 feet on an actual bridge beam. Newest segments, basically, you're looking at the precast industry is changing as we sit here today. We're looking at a series of what they call the next beams, which is the next generation of beams and structures to be actually constructed. So, which are a little bit different than some of the other beams that we've been known to, like a type 4, type 5, etc. And we're seeing now more and more accelerated bridge projects, completely precast bridges. So what we're talking about, ashdale box beams, typical, looks just like a box, and we'll have details of what these are here. I-beams, we have bulb tees. We actually have segmental bridge segments, which are typically cantilevered. We're going to talk a little bit about some of the next beams. You can do a curved beam, solid rectangular beams, box culverts, and arch bridges. Now, a lot of these projects, a lot of these types of beams, you may not have in your region. But believe me, if you work nationwide, you will find all of these different beams across the country in different segments, depending on what type of bridge structure is actually going on. So parametric sections, what we're talking about when we're talking about a precast beam, could be something similar to the precast I-beam, the deck bulb, what is a bulb T girder, a Nebraska NU girder. So these are all just a little bit of variation of the standard AASHTO type girders that we've typically seen over the years. You got the Tex.U, the tub girders, the Washington DOT tub girder. You've got box beams. You've got voided slabs. Double T's. There's 3 different types of double T's being used in the bridge market industry now. And now we also have what we call a ribbed girder bridge that actually is one of the next generation structures coming in. But you're also seeing deck slab beams, where pretty much the whole unit is basically brought in, set up, and then basically the joints are actually grouted and connected with rebar between the deck slab sections, and your finished product, once you finish grouting, you have a finished product. So let's talk about box beams. Pretty much a pretty similar structure what you see here. A lot of times they get post-tensioned after the fact. That keyway that's in between the girders actually usually 9 times out of 10 is going to get grouted with a non-shrink grout, an 1107 type material. Back when I was in upstate New York as a dealer, we used to do this as a subcontract. This is a standard box beam configuration, and you would actually fill this unit with non-shrink grout. They come back in and pre-stress or post-tension this bridge, and then pour a slab on top of it or put an asphalt overlay on top. Double box beams, typically you see on a lot of smaller bridges that don't have an exorbitant amount of traffic on it. You will see these go into place here. They're typically shorter and 18 to 24 inches in depth. So you're looking at configurations with overhang brackets and hangers, or maybe even no hangers involved with it, where they're going to put just an asphalt overlay over the top. I-beams, typically what you're looking at is what I call a I-beam here, which is the one on the right-hand side. And then you have what I call the type 4, type 5 I-beams that typically have been the standard in the industry for a good many years, typically up to about 110, 120 feet in overall length. The one on the right can actually go, I've seen those typically running up to about 150 feet overall length. These are changing also. And the big thing that you want to look at with this is, you see all those black dots, those are pre-stressed strands. So typically you do not want to drill into the top of these girders without any care or consideration that you may hit one of those strands, and if you hit one of those strands, you could do basically a bunch of damage to the girder itself, including worrying about failure with it. So when we're talking I-beams, here's what we're looking at. These are typical structures going in. They sit on top of a pier. They run typically pier to pier or pier to abutment. They sit on top. You actually have a deck that's actually going to be formed up on top of it. And the deck typically can be a removable wood form, or it can be an SIP decking or a concrete plank is put in place here. And the only thing that is actually poured on top of these a lot of times is the deck with the overhang. Everything else, performing wise, unfortunately, has gone by the wayside on a lot of these jobs with the introduction of concrete plank and SIP decking. We're taking a lot of the removable wood forming out of the picture. Bulb T girders typically have a bigger top flange than they do bottom flange. Gives them a much bigger, broader area to cover, so that you basically are having less unsupported concrete, or excuse me, for formwork, less unsupported concrete on the top of the deck. It also helps them with spans, clear spans from basically an abutment to a pier, etc. So these girders are typically longer spans, typically spaced 4 to 6 foot apart. Beams typically have a wider top flange, as I talked about. Thinner webs, a little bit thinner webs, so you don't have, and typically with concrete girders, you don't have to worry about any deflection from the girder unless you get a little bit of rolling with the girder, which is something that typically you take care of with the diaphragms being put in place. And you'll find diaphragms running on the interior from girder to girder. Typically, it's spacing anywhere from 25 to 40 feet on center. Here's bulb T's in place here. You can see how they're set up here. Now, they will actually have some diaphragms running from girder to girder to actually give themselves some lateral support so they don't roll on the project. Typically, most of the jobs today, they typically use structural steel. Some jobs still require you to do concrete work, which is actually good because that gives us a lot of additional items that we can actually pursue with a cast in place diaphragm. So here are the beams. You can see how they have a much wider top on them. Typically, you're going to see these beams here are going to have a lot of times the hangers already cast in place. Now, if you are a dealer on looking at how you would actually approach this job, you find a job that actually is bidding for this project, this municipality. You track the project through, see who the low bidder was on the project. Contact the contractor to find out who was providing the hangers for the girder, because if you need to do this early onset in the project, because if it's a precaster, a lot of times precasters will cast these beams, put them in their yard and let them set until they're ready to be used. So you need to get out early on these jobs. Hangers are typically supplied one of three fashions. One, either the precaster is supplying them. Two, a dealer is going to sell them to the precaster or supply them to the contractor to put them in place. The third way that these beams here typically is the contractor will actually supply them to the precaster themselves. So find out how they're actually being supplied to the precaster so you can pursue that avenue to make that sale. Segmental bridges, typically what you're looking at with segmental, we see a lot of these bridges popping up now. It seems that a lot of the different structures are coming back in, are coming in with a center cantilever segmental, which basically is something where they're going to be shipped out in smaller pieces, typically precast, smaller pieces, about 10 to 12 foot in width, and typically that's going to be picked up and then post tensioned back into the structure, one from each side, so that it can't balance the cantilever. And this type of structure here, you're not seeing a whole lot of overhang being formed up on here. The deck is actually pretty much self-contained here. So once it's actually closed up, other than maybe a wearing surface on top of it, there isn't a whole lot for these jobs here. The segments are actually post-tensioned, and they have a special adhesive in the joints that actually bond these structures together. Next being configurations. This is what's going on happening right now. We got double T's, the shapes. Once again, with the next beam generations, a lot of these these bridge beams here, you're basically having a wearing surface right on the top of the girder. You may have a waterproof membrane that may go down and then asphalt over the top of it. But this is something that where the beams are already with the deck sections are already cast in place and put in place. This kind of reminds you a little bit of a double T for a parking structure, and how they would actually construct a parking garage. They're doing some of this type of work now with bridge work as we speak. So we're seeing more and more of this being done. A lot more so being done in the Northeast right now. That seems to be the trial and error place of the next generation. Some of the next beams, as I talked about, deck is actually complete here. What they're going to do here is they're going to come back and grout the keyway here. They're going to connect these units from point A to point B across the units with a threaded coupler. And at that point, what you've got is now you've got a monolithic component. They're going to come in and pour the joints here. And a lot of times what they will do is, because they lifting hardware and everything in here, they will put a waterproof membrane down on top of this with an asphalt coating on top. But let's talk about bridge hangers for precasters. Okay, bridge deck hangers. They can be anything you want it to be. Typically, you're going to see a half hanger that is going to be what we call a C24, 4 APR, or a 4 PR, which is a precast hanger. But anytime you have a precast girder, you can use any component structure that, and hanger wise, that we have in our arsenal. And you'll see the hangers running through here. We're going to talk a little bit about them. The hangers typically on the bottom left-hand corner here, our C25A component is typically used in a lot of structures, especially when a hanger is misplaced or forgotten to be put in place. That is more or less like an emergency style hanger. We see a lot of guys around the world, because in South America, this is all the hanger up on the top side here, on the top left hand side, top right hand side. You are seeing a C25A heavy duty. This hanger can typically be fabricated and sent with threaded rod on it, however long you need it. We typically, in other countries, we typically supply them in 3 foot or 4 foot lengths, and the contractor will cut them down to make them fit. You basically are going to have any of the rebar or Nelson studs that are sticking up out of the structure. You can then attach it with those tighten those clips up. Basically, it's a compression type fitting around the rebar. And in the precast market, you see they actually use a plate underneath the hanger, the 45-degree clip. Now that plate underneath the 45-degree clip is there to distribute the load. Because what you're seeing with a lot of the hangers, especially in that type of hanger, that's a 6,000-pound hanger. What you're going to see is that the loading may be too much for the concrete girder, and what it'll have is you end up fracturing the concrete. By spreading the load out with that plate, you actually lessen the chance of actually having a concrete failure where that hanger is placed, especially when the size of some of these finishing machines are getting to be excessive. So it's one of the things you want to take into consideration is whether or not you need the plate. I recommend on anything with concrete beam that's 3 inches or less, usually in a bulk T, I would put the plate on it just for safety. Here's that half hanger that I talk about when I talk about C24. The 1 PR and the 4 PR, these all typically are denoted as a precast hanger. Type 1 is 3,000, type 4 is 6,000. It's a 6x4x2 precast hanger, 90-degree. Now you can get the same hanger with a 45-degree on it, and that would be a C24 4A, A meaning angle, PR. And you can get those also in a 6,000 and 3,000 pound load rating. Here's a 4A PR, this one here, and we can adjust. You'll see in the book, we have the 4A PR and a 6x4x2. Those are minimum dimensions. We can actually adjust any of these hangers to actually accommodate whatever we have here. In Texas, for example, here we have select hangers that are already designed for what type of Texas dot girder they have. Based on the flange width, we actually supply either an 18-inch or a 21-inch, depending. And what that typically does is take that hanger anchorage back in towards the center of the girder where it actually has a little bit more meat to actually hold on to. So this actually is a great option for more jobs than you look at. Don't look at the 6x4x2 and think you're limited to that. We can actually accommodate any of those dimensions here. And another thing is, all of these hangers are typically manufactured at Dayton Superior because they are MTO. They all are meet DOT requirements as far as being domestic material, because they are made with domestic steel and they are made here in the US. And they are MTO, unfortunately. Most hangers all are, because there's so many hanger sizes out there that you just couldn't stock everything. The C25 type 1, back when I was a dealer, we used to refer to this as the oh shit hanger, because that was the first thing that came out of the contractor's mouth when he realized he didn't have a hanger in place where he needed it. So this would be like an emergency fill-in, and we would also supply this with a 45-degree also, it can be. So it'd be a C25A. So, and you can get it like this with 2 clips on it to get yourself 6,000 pound load rating. This is a great option for anybody if you're doing a lot of bridge work, to keep maybe 10 or 15 in your rental, to keep them in your warehouse, just in case, because every once in a while you'll get that call where the hanger either got destroyed in shipment or transit, or when they were erecting and they need another hanger to fill in. This is a good option for that as a fill-in for most of these hangers. Now, it doesn't mean that you can't use any of the other hangers when you have to do interior wall forming. The only hangers that typically you cannot use with a concrete girder are going to be your wraparounds, which are going to wrap around the top beam planks, because you can't just wrap around a concrete beam flange. Or a weld on, because you can't weld to the girder. Now, there are some hangers, the half hangers, that can have welding studs put on place where you can weld them to the rebar or whatever. But contact your Dayton Superior representative. He can actually help you through this. But you have a wide array of whether you want 90 degree, 90, 45. You need it to tie back to hold down the hanger, especially if you're putting it on a finishing machine out on the overhang bracket, so you can actually have that tie back into it. And remember I talked about that hanger failure? Well, this is what it'll look like when a hanger actually is overloaded and the concrete, not the hanger fails, but the actual concrete itself fails. So this is compliments of TxDOT, that one of their testing labs, they wanted to see what so now they actually recommend that we actually put steel plates on all hangers that to go into their concrete girders, just to alleviate the situation. And any of the hangers with the overhang brackets, use the standard C49, C49D, or the C49S, the field modified. And to modify a C49 to get to a C49S, you just take out the vertical pipes and replace both pipes with just the outside pipe in place. Remove the inside pipe completely, and that gives you the adjustment up from 30 to 50 inches. Actually, will take it down to 14 to 26 inches on adjustment in that vertical range. Any of the accessories that you're still going to need are going to be the same things. You got the coil bolts, adjustable coil bolt, half inch by 24-inch adjustable. You've got your wall plate adapters if you wanted to decide to have an insert cast in the precast girder. You also have guardrail receptacle and extenders that are also available. And you've got all of Dayton Superior's credentials and tech data sheets, handbooks, marketing pages. Everything is readily available. Our engineering services are also out there that can actually help you with any design criteria for any of your precast structures. So any of that information, like I said, is readily available. Go to DaytonSuperior.com. Any of the other accessories, such as bar supports, etc., are also available on the website or from your Dayton Superior representative, which, if you don't know, we actually have a website. On the website, we actually have what they call Contact Us, and it'll take you to a map section. So it'll fill it in who is covering what area and what the phone number is to get a hold of that sales representative. Now, anybody have any questions here? We'll take a couple. We got a couple minutes we can handle for questions. You can use that chat functionality within the Zoom meeting. Okay, not seeing any questions. Well, if you have any questions, feel free to contact Heidi or myself at training@DaytonSuperior.com. And we will be more than happy to get back with you. And if you need to schedule a training class to go over bridge forming in depth, feel free to put that in your request and we will get that sent over to you. With that, I'm going to say thank you for your time and have a great day. And for Jerry Cruz, if he's on here, have a superior Tuesday. Thank you.